Howdy, HLIB, this is Ms. Kosh. I wanted to make a follow-up video on the mathematical induction, the trig induction proof that I had done before. I think I made that video last year, and I cruised along and did a great job until I didn't know what to do. So, I'm not sure I'm going to finish the proof, or I'm not going to start at the beginning, so go back, make sure you watch that other video. It's had over 1,000 views, and I didn't even do it correctly, so, well, there's that. But let me talk through the answer key. So our book did provide this as one of the examples, and what they do in here is, so part one, I did just fine with part one. Go watch my other video. Part two is the assumption, well, okay, and then they didn't label part three, but so then they start to work with part three somewhere. Here they're adding the k plus 1th term. Well, okay, so it gets interesting. I think I did fine, but what they ended up doing is they used one of what I would refer to as an obscure trig identity, and that's part of what I also wanted to have you work through. And this is a case of if you encounter something like this, what I would do, and I started to do it in my other video, is I made the goal. You know how we will set our goal for the particular problem? Like in this one, our goal was to show that sine of 2 and then a k plus 1 plus 1. Do I have enough parentheses? No, I don't think so. Times x, something like that. Yeah. That's a lot of parentheses. I don't know if I need all of them, but it doesn't matter. Over sine of x minus 1. That would be what I'm trying to get to. So if I get to, my recommendation for you is if you get somewhere like this on this step here, and you're going, oh, I don't know what to do, then I would start working from the goal and kind of go in that direction and see if you can kind of get to something that looks familiar. Then what we also need, but what they used is something that's rather obscure. So this is what I had, what I want you to practice also. So I pulled in my worksheet that I had made with my answer key. I called it Deriving Obscure Trig Identities. So they got down to these different things like, what we were doing is I created a situation so that you could prove a particular weird random trig identity. And so this one could be written as 2 times cosine of alpha plus beta over 2 times sine of alpha minus beta over 2. And that cleans up to give us sine of alpha minus sine of beta. Now this worksheet, if you look, I mean, I had to squish things down considerably to figure things out. I think the note that I made last year was that start at the end of the worksheet and work your way forward, because these were a little more simple, and then as you work your way backwards, you kind of build the strength, and then you can have the skills to do what you need to do on this first one. So I would practice through this. I think that the concepts that you encounter here can be helpful when we start to do some of these trig induction problems. In particular, this one needed number 5 on my worksheet. Let's go look at number 5 again. Okay, the only thing I went ahead and I think I called this, I multiplied that 2 over, and I said sine of alpha plus beta plus sine of alpha minus beta is equal to 2 times sine of alpha cosine beta. And so that became important. See how that was kind of an easy, that's what they used way back in their answer key. Yeah, so I think, oh, I don't know what they did. They had, oh, okay, so this part right here, because this is this. So these two, yeah, okay. They're saying that A, or alpha, is x, and then they're saying that B is 2 times k plus 1 times x, so 2k plus 1 times x. And so now we've got an a plus b and then an a minus b, and then we can put that together. Well, they didn't. All right, you guys, this one's a tricky problem. It's kind of surprising to me that they made this the example. Good luck. Hang on, let me see. So this is this. Oh, okay. So they took all of this. Okay, let me try this. So we're saying this is A, and so it's going to be sine 2 times sine of A times cosine of B. You guys, I don't know what they did. No. No, 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 no. Okay, hang on. I'm looking in the wrong spot, perhaps? Is this what they're trying to say? That this is 2 sine A cosine B, and so then they can expand it out to here? Oh, that's what they're doing. They're stating this after they went from here to here. You know what? This is a very humbling video for me to post, and I'm going to do it anyway. So math is challenging, you guys. You got to keep working at it. Okay, then how did that? So then from there, what did they do? They then took each one of these. This is they factored out an x. Oh, look at that. Okay, so once they got oh, that's what they did. I'm so sorry. Okay, so this right here is this right here. Then this here becomes this here. And then they factored out, okay, so from, then once we have, then they factored out in this part right here, they factored out an x. And so there's that 1 from this x right there. And then they have this 2, k plus 1 times x. And then they had, what did they do over here? They factored out, did they factor out an x here? How did they get from this to this? That's an x minus 2. Oh, okay. What they did here, x, they have x minus 2kx minus 2x, and when they put that together, they realize this is minus 2kx minus x, and then they could factor out the negative, and then they could factor out the x. Yeah. Yeah, so then that term canceled over here, and then we were left with this part right here. Should have been our goal. Well, not entirely our goal, because there's also the minus 1. But our goal, this right here, matches that. Oh my goodness, you guys, these are tricky. So I don't know what to tell you besides practice, and sometimes these weird, obscure identities can be really helpful. So I'll try and find a list of them and post that for you. I've had one in the past where there's like product to sum and sum to product and different. They have different names like that. So good luck, practice, work hard. Let me know if you have questions.